What if everything we thought we knew about the universe's beginning was wrong? The James Webb Space Telescope just uncovered something so massive, so unexpected, that it's rewriting cosmic history, and scientists are stunned. For centuries, humans looked to the night sky and saw only points of light stars twinkling in silence. Then we built telescopes, and suddenly, space wasn't silent anymore. It was a symphony of light and structure. But now, with NASA's James Webb Space Telescope, our most advanced space observatory, we've unlocked something far beyond beautiful images. We've opened a window to the universe's past. A past that's not what we expected. The James Webb Space Telescope, or JWST, is more than just a powerful camera floating in space. It's a scientific time machine designed to capture the earliest light in the cosmos, light that began its journey over 13 billion years ago. This infrared light is invisible to the human eye, but Webb's golden mirror was engineered specifically to detect it. Positioned a million miles away from Earth and shielded from the sun's heat, JWST remains ice-cold, allowing it to see even the faintest traces of ancient light. It peers into what appears to be empty sky and captures time-stamped memories from the birth of the universe. Its mission? To study the cosmic dawn, the era when the very first stars and galaxies were born. Scientists expected to see small, irregular blobs, primitive clusters of gas made up mostly of hydrogen and helium. These baby galaxies were predicted by decades of theory to be the humble beginnings of everything we see today. But what Webb found shattered expectations. In July 2025, JWST focused on a tiny patch of sky, an area previously studied by the Hubble telescope. This time, JWST stared longer and deeper, collecting faint signals for over 100 hours. And then, the data came in. What scientists saw left them speechless. Instead of tiny, chaotic baby galaxies, the image revealed 6 massive, well-formed galaxies that existed just 300 million years after the Big Bang. These galaxies weren't small. They were giants containing tens of billions of stars and exhibiting mature structures like disks and bulges. In simple terms, it was like discovering fully grown adults in the universe's baby photos. And that wasn't the only shock. These galaxies also contained heavy elements, carbon, oxygen, and more. According to every existing model, those elements take generations of stars to form through nuclear fusion and supernovae, but these galaxies had them already, only a few 100 million years into the universe's timeline. That means stars had formed and died far earlier and faster than anyone thought possible. This single discovery calls into question everything we thought we understood about how galaxies grow. According to our best theories, galaxies build up slowly over billions of years, merging and evolving like cosmic Legos. But JWST is showing us another possibility, one where galaxies can rapidly form in huge bursts, something that might resemble an old theory known as monolithic collapse. Even more radically, it suggests that maybe the forces we thought governed cosmic structure, gravity, dark matter, might behave differently in the early universe than they do today. This isn't just a surprise, it's a direct challenge to the foundations of modern cosmology. And that's the beauty of science. JWST wasn't launched to confirm our models. It was sent to test them, and now it's forcing us to reconsider the entire timeline of the universe. If galaxies could form so quickly, then planets, and maybe even life, could have started earlier than we ever imagined. It also deepens the mystery of how supermassive black holes, some seen at very early times, grew so rapidly. The implications are enormous. Astronomers are now working tirelessly to verify the stunning results uncovered by the James Webb Space Telescope. The discovery of massive, mature galaxies existing just a few 100 million years after the Big Bang is nothing short of revolutionary. And the scientific community understands the weight of what's at stake. If these findings are accurate, and so far, every test confirms that they are, then they could fundamentally reshape our understanding of the early universe and the timeline of cosmic evolution. Verification, however, is a meticulous and time-consuming process. These scientists aren't content with a single observation, no matter how groundbreaking. To ensure the discovery isn't an observational fluke or a misinterpretation of data, astronomers are already preparing to re-observe the same region of space using JWST and other instruments. By capturing multiple sets of data from the same galaxies, they can confirm not only their existence, but also their age, size, and composition with greater accuracy. Repetition is one of the cornerstones of science And in a discovery of this magnitude, nothing can be left to doubt, beyond revisiting Thoth. On the other hand, if additional surveys reveal that these massive galaxies are incredibly rare, perhaps isolated cases formed under very specific conditions, then the implications are still profound. Even a single confirmed instance of such a galaxy challenges existing cosmological models. Rare or not, their existence implies that something is missing from our understanding of how matter behaved in the universe's infancy. Whether this something is a new kind of physics, a flaw in our current assumptions about dark matter, or an unknown process that accelerated galactic growth in the early cosmos, astronomers are determined to find it. To aid in this verification process, astronomers are collaborating across observatories and disciplines. Researchers in spectroscopy are analyzing the light signatures from these galaxies to determine their redshift, the measure of how much their light has been stretched due to the expansion of the universe. Accurately determining redshift is crucial because it directly relates to how far away and therefore how old these galaxies are. If the redshift values hold up under scrutiny, then these galaxies truly existed just a few 100 million years after the Big Bang, which is mind-boggling when you consider the complexity they exhibit. Meanwhile, theoretical astrophysicists are racing to adapt or even reinvent existing models to account for what JWST has uncovered. This includes reevaluating the rate of star formation in the early universe, the behavior of dark matter in dense regions, and the possibility that some galaxies may have formed through processes far more efficient than we ever thought possible. Simulations that previously matched Hubble data are now being pushed to their limits to try to replicate the rapid formation of these galactic giants. In most cases, the simulations come up short, hinting that new physics might be required. Amid all this, other space telescopes and ground-based observatories are being looped in to provide supporting data. Instruments like the Atacama Large Millimeter Submillimeter Array, ALMA, the European Southern Observatory's Very Large Telescope, VLT, and even NASA's upcoming Nancy Grace Roman Space Telescope will play key roles in this ongoing investigation. By combining different wavelengths of light infrared, radio, visible scientists can build a more complete picture of these galaxies and the environments in which they formed. In the grand tapestry of science, moments like this are rare and thrilling. It's a time when decades of predictions meet the raw power of observation, and the universe pushes back, revealing just how little we truly know. Scientists around the world are treating this moment with the seriousness it deserves, knowing full well that what comes next may not just revise a chapter in astronomy textbooks, it could rewrite the entire origin story of the cosmos. The cosmos has spoken, and finally, we have the tools to hear it. Stay curious, because the universe is far stranger and more magnificent than we ever dreamed.